the last years spending a couple of times with Cumulocity. So I'm happy to present this topic today, as it's like a mixture of the things that I did the last years anyway. And I think most of you probably have heard of Analytics Builder anyway, otherwise you wouldn't have been here. It seems to be quite a lot of interest actually in it, so I'm happy to see that. And well, for those that haven't worked with Analytics Builder or haven't seen anything of that yet, you just start with a bit of motivation. Then I'll have a quick look at, like Stefan said, Apama, because that is going to be the background of all the things that we're going to talk about today, and the essential core of everything that is streaming analytics related in Cumulocity. And then I hope to spend most of the time actually just coding stuff, showing you how Analytics Builder blocks are created, how you manage them, and where to look for help if you get stuck, or where to look for inspiration via documentation, things like that. So for today's session, I thought it would be nice to have actually live data to show you the block really working. So what I have here is my phone connected to a Cumulocity instance. It's well, just one of my sandbox instances running on EU latest, so it's the last Cumulocity version, but really streaming analytics haven't changed a lot in the last 1 or 2 versions at least, or at least the topics that we're talking about today. So what you can see is my phone sending data. So if I move the phone, I'm actually seeing some acceleration in Cumulocity, so X, Y, and Z axis, which is pretty nice and cool for demo, but for analytics, analytics-wise, having 3 different input parameters is sometimes not really helpful. So you see it's going up and down, but we're not really sure what that really means. So what we're doing today is, well, just putting a small block, which will take all the inputs, acceleration input from any device and make something meaningful of it. So this example is going to be rather simple, as you can imagine. So it's just a simple formula that we're going to apply, but everything that I'm going to show today is really the base for anything that you want to do within your block. So it can come up easily with more complex calls and scenarios. But well, for the understanding for today, just stick to a simple formula. And what we're going to do is just normalize the values. So we are taking 3 input values. We're doing what is, well, called a norm. You have seen this formula in this form and any other one, where we square the input parameters and, well, just get the basically for absolute value for the vector that is represented by these 3 input values. And with this absolute value that we get, we can just look at how this value changes over time. So what you can see is, out of the 3 input values that we have, with really up and down, and in the middle, it's not really clear. And what is happening, we get clear spikes, for example, that will tell us how much force there was in the acceleration movement. So that's actually a common case. So typically use cases for anything that you want to do in blocks are repeatable formulas or steps that you want to do. So or to provide other people to reuse. So this is one that could be, for example, useful in if your case you are dealing with these kinds of inputs in your domain. Oftentimes we see that blocks are domain specific. So if you have certain KPIs that you want to express with the blocks, then, well, you just go ahead and code your own custom blocks. And, well, there is not really a block yet for this. It's like I said, a bit specific for our use case, like so many of these things. So we're going to just translate that to a single block. So, well, question is now, how do we do that? How do we start with it? And before we go to that, just a quick detour to what we're going to see today. So, like I mentioned, underneath all of things is Apama sitting, calculating the actual stuff that we're doing in the blocks. So I think we start with explaining what Apama is, just to get you an understanding on what the foundation is of all of this, because I think that will be helpful in finding out how this works and get more information on it. And what Apama really is, or was, or wasn't still is a standalone product. So it's a streaming analytics solution that, well, is dealing with complex events, where complex events can really be just structures with fields of different types. And we are listening on these events coming in, pattern matching those events. And if there's an event that we are interested in, we're doing something where this something is really programmable. And in the end, we just spit out events again, where these events that we are spitting out can be really anything what we define. So you might have seen similar things if you're having worked with agent-based systems or other streaming analytics solutions. So that's quite a straightforward concept. And really, this is all Apama is doing. So events coming in, pattern matching, figuring out what to do or if to do something, spitting out events. And in the case of Cumulocity, now we have a couple of locations where Apama is used under the hood. So I have been working with smart rules, which are just rules that act on Cumulocity events, predefined, and you specify what events should be triggered in case of, for example, threshold breach or something like that. So what we're getting is measurement inputs events in, for example, and creating an alarm event. And Apama is the one doing the pattern matching and the actual logic behind the scenes. Then the analytics builder that we're talking about today is really similar to smart rules, but gives you more freedom. So instead of just having some parameters to set, you can actually now combine blocks to describe our own logic. Also still in a UI, but more than what we had to do, could do in smart rules. Then if that is still not enough, we can go back to the basics and program Apama in EPL. So we haven't going to look at this. So EPL, programming language of Apama, to define actually what events we are interested in, what is going to be the logic that we are executing on these events, and when and how to send events out. So small coding editor if you want to build an into Cumulocity for and mainly things that aren't covered with smart rules or analytics builder. And then moving even further to the right, we get to the area we are not really integrated into Cumulocity anymore with, for example, custom microservices based on Apama, or even a standalone Apama correlator running somewhere and just connecting to Cumulocity. So moving from left to right, you gain more power on what you can do with your Apama installation. So with the external correlator, you can also make use of other connectivity adapters, etc., or persistence. Code anything that you want, basically with plugins written in also other languages. While we are on the left side, we gain the immediate benefit of having integration into Cumulocity and for rather simple use cases. So today we're looking at the analytics builder, which is kind of a middle thing between EPL apps and the smart rules. We'll see that in a moment in terms of how it works. So we're still having to do with EPL code, because that is really the only thing that Apama understands, or the correlator understands. So we need to write a bit of EPL code. on one hand, and then on the other hand, we also have to define how it looks in UI, because we are integrating with the Cumulocity UI here for our blocks. Okay, so how do we start with it? I would say the most easy solution is still just going to the either tech community or the software AG side and looking for the Apama community edition. There's a download available. I also put it in the link here. And what it will give you if you download it is the Apama installation, obviously, with the correlator and all the tools that you need, plus an IDE based on Eclipse for maybe the people that still know Eclipse, which is called the Software AG Designer, and which has some Apama plugins in it, which will get you started with just coding Apama in general, or EPL in general, and starting a correlator. Then the second part that we'll need is the Analytics Builder SDK. So this is written as open source project. I'll also put the link here into the slides if you haven't found it yet. It's just a small tool set extending the capabilities of the Apama correlator with some predefined monitor files, with some pre-existing tools for creating those blocks, and a command line tool to upload and manage those blocks on your instance. So you want to go to the page, just download the release package. When working with or looking for the release package, I would ask you to check the actual version that you need. You can check that if you go to the Streaming Analytics application, scroll down or just look down, you will see a small hint about the version. So in this case, I actually have 10.14 Euro 3. By the way, this is also next to the diagnostic downloads in case you're running into situations where something is not working as intended. And then you go back to just the GitHub page and download the correct release version. So in my case, it would have been 10.14. I downloaded actually 10.15 to see if there's some news in there. We'll talk a bit about this in a second. In general, it should be backboard compatible. So if you're downloading the latest version, it should work with older versions. There are potentially some inconsistencies between versions. So rather pick the one that is matching your Cumulocity version if you are working with, for example, non-cloud and or older versions. The other setup that I really haven't tested myself, but that should work, is Visual Studio Code. In case you're familiar with Visual Studio Code and the dev container concept there, there is a Cumulocity Analytics dev container available. It hasn't updated to 10.15 if I'm not wrong. So you might have to tweak it a bit if you want to have the latest version available. But apart from this, just works. There's also an Apama extension as well as a Python Pysys code extension available. So it will give you syntax highlighting and things like that in Visual Studio Code as well. So the Visual Studio Code and Software AG Designer, they are helpful. They're not really required. We will see that in a second. It gives you things like syntax highlighting and autocorrection and errors and things like that you actually want when developing typically. But there's nothing blocking you from just taking a notepad or whatever and coding a bit EPL as well if you are not happy with any of these choices. So what I'm going to do is today just use my Software AG Designer. Looks a bit like this. So what I'm going to do is just create a new project. In this case, an Apama project. Could be really also an empty project. I'm actually not really interested in any of the, let's say, Apama specific folders. Leave everything by default. And well, what it will give you is just in structure, like I said. Actually, we're not interested in most of these here anyway, so maybe just that. All we need actually is a folder where our blocks are going to be. So creating a blocks folder. And well, that's a start setup that I'm going to do in Software AG Designer. But before starting with coding, let's have a quick look at what we actually need to code and what a block actually consists of. So if you have worked with analytics builder, that might be not too far from what you have seen. So all our blocks are listed on the navigators list on the left. So we have a category and a name that we need to define. Then the block itself will have an input port or multiple input ports with name and types. It will have output ports, again, also potentially multiple output ports with certain name and types. And then there is the magic happen in the block that we need to define. So the processing block logic. So how to translate the inputs to the outputs. In case we are interested in input parameters for the block, we also need to define what parameters are available, what types are there, which of them are necessary, which not. And as well as for all the documentation. So the documentation is essentially part of the code that you're going to do. So that makes sure that there is documentation available. So it kind of urges you to build documentation in it for users of your block. So we have a look at how to do that as well. So yeah, here again, the analytics builder block link. And the GitHub page actually also contains a lot of good documentation, I would say, step by step. And well, the first step then is just creating a skeleton for our block. So it will look like this, and it might look a bit strange if you haven't worked with EPL before. But in the core, all we have to do is define our process action. So $process, that will give some input values, which are called $input something. And in the end, we are going to produce some output, which is going to be $set output. So this is, well, I would say the skeleton. With using some of the analytics builder framework events here. We talk a bit about this in a second, what it all means. But that's a good template here. And before we dig deeper a bit, just a quick look at EPL, because I know probably some of you haven't worked with it. It's at least to give you an idea of what we are talking about and what are the most basic concepts, because I would repeat them over and over again. So like mentioned, EPL is an event-driven programming language. Like, for example, Python, it's interpreted, so you can upload it to the correlator. The correlator will take these things that you wrote in EPL and start to execute it immediately. So in case we're listening on events, it will listen on the events and do something accordingly. This event-driven programming is quite nice. It enforces loose coupling. We will see that, how it works. So we are just talking over events. And it's non-blocking. So there you don't have to really deal with things like threading or mutexes or whatever from other languages. We're just sending an event, and either somebody is listening on it or not. And when this event will be handled is just a matter of correlator and the listeners. So the core concepts are all in this small page here. So we are doing coding in something what is called a monitor file. And our main unit is also the monitor. So monitor, if you're coming from programming languages, yeah, Java or Python, it's just really like a class. So a monitor can have actions, it can have fields, and that is what is being executed in the correlator actually. So, and we have listeners. So in our case today, not going to look into that. But in general, how it works is you just define on what you're interested in by defining an on or on all listener, for example, and then specifying the event that you're interested in. So in this case, we are interested in all warnings of certain source. Then we have events. Events, I would say similar again to classes or records from other languages, are just really information or structured information and that are going to be passed from one monitor to another if you want to. And then we have actions. So these are like your usual functions or methods in other languages. You can freely define these actions with input parameters, return values. There are some magic actions that are called by the framework or the correlator that we are having a look at. But apart from this, they are freely configurable, and you can just structure the monitor file like you want. Last but not least, the thing that the event flows over from one monitor or one listener to another one is the called the channel. So channels in Apama EPL are just really names. I mean, there's a bit more background to it, but there's nothing special to channels. So you can create them at any point by just giving them a name and then send events over these channels. So it works a bit more like pub/sub from other languages, where you specify a channel that you're interested in and the event, and then everybody is free to send events to the channel or listen on it. Just quickly glancing over some of the elements of EPL. So EPL is a statically typed language. We have basic types, like string, boolean, integers. There are some additional types, like, for example, the location type. A listener itself would be also a type, for example. And as a special type, we also have the any type. So that can be literally anything. In this first example would be an integer. In the second one, it would be an event. So what are events? Like I said, it's really just a record or a structure that has events, has fields of certain type. The event itself can also be complex, so it can include other events, can include other complex data structures as well as actions. So that's an event. And then, well, the actions looks like this, so not too far from what you've seen in other languages as well. Just it's called an action. We give it a name, some input parameters. Then we define what it returns. If it doesn't return anything, we don't define anything. And then we return a value or not. Just some more commonly used data types quickly. The sequence, which is really just array-like. Created like this. A sequence will always have a type. In this case, it's a sequence of type string. We can access this array by index, and we can iterate over it. And the second most used one is the dictionary, probably. Just like a map, for example, a hash map. We define the key and the value type. Then we just define the entries like this. We can access the entries by, well, again, like this index structure. and we can iterate over the dictionary by iterating over the keys, for example. Last but not least, the thing that I wanted to show definitely is the optional type, because this is one of the biggest differences to other languages. EPL doesn't have a null type, so there is not really an option to say this doesn't exist, or it has not been set. By default, anything that is not initiated will have the default value. In case of strings, it would be an empty string. In case of float, it would be 0. So if you want to really say, okay, this value is not there, you would rather take an optional. And optional works like optional, for example, in Java, where you say this value is optional, so it is an optional of a certain type. Could be also an optional of float, for example. And then you check if the value is present with either the if present statement and doing something with the value in it, or by using any of the methods on the optional type. So we see that how it's used later on, for example, for input parameters or input values. So there's a lot of more things to show regarding EPL. It was really just a quick look. There's a really good documentation already available on the SoftwareAG documentation site, so documentation.softwareag.com. If you look for Apama, you will find the web help as well as the PDF version, and then the EPL reference will give you all the EPL syntax elements and built-in types again. Okay, so this was like a really quick EPL crash course. So just have a look at how it works, and it will probably help in understanding. So like we said, what we need to do is define the skeleton of our block. So I will just create a event file. In this case, we are going to name it non-block. And well, I'm doing it via the IDE, so it's asking for some other things. If you're doing it via a text editor, it doesn't really matter. In fact, we can also get rid of this. And what we need to do is just define the basics of our block. So we need to assign it to a package. So package is like a namespace. Could be really anything. Typically, that would be the company or some package to that doesn't collide with any existing package. So should be also I'm not using. And what we want to do is using some of the analytics framework things. So we are going to use the block base as well as the So the block base is the one that is containing all the functionality required for running a block. EPL doesn't have inheritance like other languages do. So, well, that's why we're using composition. Means we are having a single element called base in our event of type block base, and it's called base. So this actually needs to have this name and be of this type, just because how the magic of the framework works. Frameworks in general, like tend to call your code, not the other way around. So the framework makes some assumptions on how the code is structured, how things are named, etc. And this base is one of them. So as you can see, it's not finding anything of the things that I added. That's because I haven't really added the analytics builder bundle. So I will do that. The whole setup and how to integrate it in Designer is also described in the documentation. I think I have it also on the slides. But once it's done, we will just look for the Analytics Builder SDK home and take the definitions from there. So the other thing that I showed was like you need this process action, and this will take actually 2 parameters at least. Well, I think 1. So one is the activation. And as then following parameters, we would typically add all the input values that we're expecting. So in our case, we'll just start really simple. Input something, but it's just like value. Then the other one, defining an activation flow. So what we're doing is defining a field. Again, this might look strange if you're not coming from EPL, but we're having a field of type action. So actions can be passed around as parameters or set as field, like strings or float values or other types. So we're having a field called setOutput that will be called whenever an output happens. So this is like just like the base structure that I showed. Doesn't do too much. So what we're going to do is now look at our logic. So we wanted to take 3 input parameters. So one would be the x value, one would be the y value, and the other one would be obviously z. And like I said, there is no kind of null. So if I define it like this, x, y, and z would be 0 if they are not set or anything else. Let's say we are interested in just getting values from x and y and make that optional. So in this case, we would define an optional of type float instead of just a float. And then in our logic would be the small formula that I showed. So we are taking the input x, squaring that by just multiplying it. So doing the same. Sorry, my touchpad isn't yet. And well, we could do the same for that. Let's leave that out for now. And what we do is then just taking the square root from it. So there's a method called square root on the type float. So now we get x squared plus y squared to square root. And what we're doing is just assign that to a result. Assigning is done by colon equals. So don't confuse it with the equals operator. And then what we have to do is just instead of returning now this result to anything, we have to call this method here. So this is a field, but it's also a method. Output with our activation that we got in as a parameter and the result. So what it will do is tell the framework that our output port should be set to this result. So, well, that's actually the whole logic for now. But if I upload it now it wouldn't really work because it's missing all the extra definitions for the doc and the name and things like that. So how the framework is solving that is by just defining everything in doc strings. So again, coming from other languages, you might know that if you have like comments on certain fields or actions, they will appear as document in the output. And we can do the same with Apama. So there are things like param, result, deprecated, and things like that to define certain aspects or to document certain aspects. And the analytics builder framework just takes that concept and includes some additional fields here. So I just copy and paste that from what I have prepared. So like these magic constants, they are all defined in documentation again, but the most important one I will go through. So we are going to have a block called norm, and this is defined by the first sentence in our event description. So this first sentence here defines the name. We'll have the block category calculations. There are other categories in the analytics builder set, like utilities or logic and things like that. So you just define the category you're interested in here. Or the derived name we don't, I think, now. And that's everything that we really need for describing where the block should appear in the navigation. Then we need to define how the input parameters are named, what they are, describe what they're doing. In this case, we're just adding documentation to the process method. Oh, I see. Should be really just process. In this case, we're using the built-in param to describe what each and every of them is doing. And in case that we want to rename them in the documentation, like X, Y, and Z may be not really helpful, we can also add the $input name doc string format to set the name. The format in this case would be input name, value, and then the name. Like you see, anything that is really starting with a dollar is owned by the framework. So typically your code wouldn't be or haven't that much dollar signs over it. So anything that has a dollar sign is probably related to the framework. So things like this process action, the activation that is being injected, all the input params, and the output action. Okay, so
just a time hint, you have 15 minutes left now.
Yeah, okay. So this is already the base. Just quickly adding one more comment here. For the output, because that needs to be documented as well, what it's doing, what it's representing. Again, follows the form output as the first sentence is the name, and then the description will be after that. So that gives us all the logic for the block that we need right now. How can we test it? So how to test it is just by uploading it, and how to upload it is by using the analytics builder CLI. So there's something called analytics builder. Executable. It's in the test framework. You just might have set up your command line to actually find it, and it comes with some helpful commands. So for one, we can check what is already on the tenant, so list extensions. And then we just need a blob of things like the Cumulocity instance. the username and the password. In my case, I also need to specify the ignore version because I'm using a different analytics builder version than the tenant is. So if you're picking the correct version, it shouldn't be necessary, and in general is not really recommended. Here's extensions. Okay, doesn't want that. This case, so as you can see, it's nothing giving back because there's nothing to show. So what we're going to do is just create a block out of this code that we have by telling the analytics builder toolkit to pack that. How that works is just really by creating a zip file. So just go to the place where the code is. Let me quickly make that bigger. Whatever. Okay. And then run a command. So what we do is build the extension by taking the norm block folder as an input and put everything out to a norm block.zip file. So if I run that, well, it creates the zip file. The zip file itself is not really interesting in our case, so it will have a folder called files. Then there are the blocks in there, which includes our code. So it will just copy the folder structure like we have it, and it will create some messages that we look at on later. So that's everything in the zip file, and what we need to do then is upload the zip file. So what I do is upload it. I have also a command prepared for that. Okay, so again, it's just build extension. In this case, we're giving it input name, so the norm block zip, the tenant name, in this case, my sandbox, the username and the password. And now if we check available, it shows the norm block is there, so we can check that on the tenant itself. Let's see. So I'm going to Analytics Builder and just check the available blocks under calculation. We can now see the norm block that was added. Just let me grab it here. So you can see it has X, Y, and Z as an input. It has output because that's what this output method was called. It has all the documentation that we said. So the name, description, and for the input and output ports. And well, the logic should work as expected, so we can test it now. We haven't really done anything with the Z, so I'll leave that out. So I just connect X and Y. And what we'll do is take the X, Y, and Z input values from my phone, do the processing, and then create another measurement called norm acceleration. So let me save and activate. It hasn't complained, that's good. So I'm going to my device. To see if the new measurements are coming in, or the right measurement. So we can still see data is coming in from my acceleration sensors. But now if I scroll down, I can also see that I'm getting input values for this derived value that I'm sending the other model. So I can see now, if I move the phone a bit, there's a single line going up and down. If I would to throw my phone across the room, the acceleration would behave a bit differently, obviously. So it's a nice way, for example, to find out if it's falling down or experience some shock. If I lay down the phone, what we'll see is the phone, okay. The value should stabilize, so there is no acceleration really on it apart from Earth's gravity. And so should my value also go to, well, nearly 0. So what you can see is the value is produced each and every time we get an input value, and it's really fine granular. So we didn't really do much things like rounding or stuff like this. So we're getting these odd float values. So that's one thing how we could improve our block here. And actually we're going to do that by just adding some additional state and parameters. So given the time, we'll just copy and paste some things again. And just explain what is happening. So there's some framework magic again involved by defining the parameters, and it looks like this. So you're having your block name, and then underscore, and then dollar parameters indicates the framework that this is going to be the definition for the parameters that your block is going to use. In our case, we want to have a threshold value, so I'm just having a float threshold here. If you have other parameters, like you're having a string message or whatever, you would add these as part of the event definition here. Again, the doc strings are used for defining the name and what is the parameters doing, so we can see that later on in the documentation. If you have some default values, you would define them like this. Again, default with a $sign before it to indicate it's used by the framework, and that's everything. The other interesting thing here is the parameter validation. So our threshold should be absolute positive because it's going to be what we're going to use. Every time the value changes, like an amount of X, we want to submit a new output event. And if it's below that, then we just don't emit anything new because, well, why should we? And in this case, we're defining this threshold value as a float, and it must be positive, therefore. And we're just going to write the parameter validate method. So having this action here means we can check the parameter fields. So $validate will be called by the framework again, and before initiating the block. And this code block here will then check the parameter values. So in our case, if it's below 0, or if it's not a number, we're going to throw an exception. And the exception handling is done by just, well, calling again a framework method called getLocalizedException, and giving a section message. So this message comes from a message JSON file. I hope I have prepared that, I'm not sure. So would be just messages.json. And then this would be the key. And then the value would be the actual measures. Oh, no. And that's it. So you can add multiple messages. You can also add placeholders for the message. So like this. So giving the arguments as an array, and then in your station message structure, I have to look that up. I think it's just so indicating that this should be filled with a placeholder instead. So this is defining the parameters, and it will give us this parameter block. The other thing is the state. So state in blocks is also a bit tricky, even though we can define fields in the block itself, like we did here with the base. It's not really good to do so, because the framework then doesn't have really a chance to, for example, handle the state for across devices and things like that. So what we're going to do instead is all the state that has to be kept for our block is going into something called $state. And what we do in our case is we just need to remember what the old value was to compare it to the new value. So that is going to be our state. And this will be injected also into the input process action. So that should be state. And this should be actually called So, and defining like this, the framework knows it needs to inject the latest state for your block in here, what type it is, and then you can use this state in your process logic. So what we do is check if the old value exists. If no, then just override with our new results. If yes, compare if the result is bigger than old value plus our threshold and make it new one, like this. For making use of the parameters, we actually also have just a field called parameters. So that will create a parameters instance, and which can be used then in our processing block. So again, it's just a bit magic of injection done by the framework, but I think quite straightforward once you get used to it, and just from the logic point of view. Okay, so given the time, just let's build and see what happens.
Yeah, we're nearly out of time. I think this.
This will be the last one for the day. I think I have some things about testing, but yeah.
We can send it later on.
Yeah, I can send it later. Okay. So building. Let me just copy and paste the code again. By the way, there's also an option to just build and upload the zip in one go. Might be preferable if you're just doing quick development. I like to have the zip file actually to check things. Okay. One thing to keep in mind is that blocks will only be changed once you restart the correlator. So that's why we are having this -- restart on the analytics builder command line tool. And this might have an impact on the productive environment that you're working with. So if you are having a lot of users in your environment or a lot of rules executing, you don't want to upload too often, but make sure it once before you upload something. Also because having errors in your block might cause the correlator to crash, going into like a fallback mode when it crashes too often. So the second part would have been like showing you a bit about testing with Pysys, but that we keep for later on, I guess. So for now, we just have a working block. We have now the threshold parameter here. We can set. So if I say 0.5, for example, will be stored by the framework. We also now have the parameter description here available. Let's save that again, see how it behaves. So let's see, it's nothing doing. We can see it stays the same. Also, if I move that slightly, it shouldn't really give an output. And if I check the phone, it starts to actually point out something because the value has changed across our threshold only. Okay. Well, that's kind of the first version of a really simple block. There are a lot of more things to cover that we can't do, testing being one of them, again, like usually. You're probably interested in how to do input and output blocks. There are things like timers for asynchronous handling. We have more magic methods like the init and the respawn init method. There's all things around partitioning and worker threads. All these things are quite nicely described in the documentation, so I would urge you to have a look at this, or feel free to write me an email in case there are any questions open. So I will skip the testing section and just leave that in here as well. But at least mention that there are also some projects around the analytics builder blocks, namely some existing predefined blocks. So for once, they are available in the samples folder of your SDK, as well as on the GitHub project you can check. And more importantly, also the contrib repo, which has some existing custom blocks. So if you are looking into implementing something, maybe check that repository to make sure nobody else has done it yet for you, or just add your own custom blocks to the contrib repo. I guess people are also happy about that. And then the administration UI for Analytics Builder will allow you to add and manage extensions without the CLI. So that might be helpful in case you want to do it without a full development environment. So you can upload and zip here, restart the student analytics application at any point of time. So this has been done by our pre-sales colleagues, Murat, and is also available via GitHub open source. If you feel there's something missing still, feel free to tell us your idea. There is a section specifically for student analytics in Cumulocity, and I know we're happy also about any ideas that we get. Okay, some doc links and then maybe some quick Q&A. Sorry for taking all the time again.
Yes, I'm opening the mics. I'm sorry, we're already 1 minute over time, but if you have any questions, we do a very quick Q&A here. So if you have any questions, just open your mic, unmute yourself and ask it. I think some of the questions already have been answered by Sandeep in the chat, but if you have another one, go for it.
Great, thanks.
Any questions? Everything answered already?
Okay.
3, 2, 1. Okay. Then thank you very much, Mario, for the presentation. I also stated in the chat already, we will provide the slides and the code examples later on. I will also upload the recording. As normal, you will get the link very soon after this meeting. Hope to see you soon in one of the next events. Have a nice day, guys.
Thank you, everybody.